Hello everyone, in this video we're going to go over the multiple choice questions and the short answer questions for the review of the final exam. So the first question says, suppose that it takes a point 84 seconds to travel around a circle. How long will it take for the point to travel from an angle of 5 pi over 6 radians from his original position? So the first thing is that you gotta remember that, or you gotta check that how much is a pi over 6 of a circle. So pi over 6 is technically 1/12 of the circle, right? Why? Well, because if you multiply this by 12, then 12 pi over 6 is going to be 2 pi, which is the entire circle, right? So pi over 6 is like 1/12 of a circle. And so essentially what we're doing here is if it takes 84 seconds to travel the entire circle, so 1/12 of a circle, which is what it takes to cover pi over 6, is 84 over 12. So that means that to cover pi over 6 is going to take 7 seconds. Just pi over 6. But now, because we want to go from to travel the point to the 5 pi over 6 from the original position, then what we're calculating is 5 times this 7 seconds. So 5 by 7, it will be 35 seconds. And so that will be answer C. Now, question number 2 is about a sinusoidal function. And in here we have that B represents the amplitude, 2 represents the midline, C represents the speed of the wave that we use to calculate the period. So we want to know what the maximum value of the function is. Sorry, the maximum value of the function is 7. We want to know which of the following is the minimum value. And so if it's 7 we can calculate as 2 plus b, because it's the amplitude plus the midline. So that implies that b, so the amplitude, is going to be 5. And so if we want to calculate the minimum value now, that will be 2 minus 5. And so that will be minus 3. So this is the answer here. Remember that the maximum is midline plus amplitude, and the minimum is midline minus amplitude. For number 3, we have that the period of a sinusoidal function is 8, and we have that the maximum value of f of x is 5, and the minimum is minus 3. And so if f of 2 is minus 3, we want to know what f of x equals 5, where f of x equals 5 occur. So now we can make a line here and just put these values. So let's see, f of 2 is minus 3, and then f of 2 is minus 3, and then we know that later, because this is has a period of 8, we know that this in f of 10 we're gonna have minus 3 again. Okay, so to get to a point, to get to the point where 5 occurs, which is the maximum, the maximum is going to be in the minimum, in the middle between the two minimum values that we have over here. So since this is happening at 2 and at 10, the minimum value is going to be 10 by 2 divided by 10 plus 2 divided by 2, so it's going to be in 6. So just in the middle between the two minimums is when the maximum is going to occur. And so that is answer B. Now, 4 says a zip line has an inclination of 25 degrees and a rider speed average is 48 meters per second. We want to know what is the horizontal distance the rider is traveling if the trip takes 21 seconds. Now, to be able to calculate that, we have the speed and we have the time. So if you remember, a speed or distance is really a speed by time. And so if we have 21 seconds times 48, that is going to provide me the distance. And the multiplication of this two is 108. That will be a calculation that that we can use from the zipline. So this is 1008 here, and so this is forming a triangle over here. The zipline has an inclination angles of 25. And so, of course, we have from this triangle, we have the hypotenuse and we have a triangle. So we can find the horizontal line. Don't be confused because this number is showing up in here. What you're trying to find is this distance, which is the horizontal distance, not the diagonal, which is the zip line. So now this factor here is the adjacent to the angle. So adjacent over hypotenuse is the cosine of the angle. So we can now find the result by doing 1008, the cosine of 25 degrees. Okay. And when we compute this in the calculator, this is going to give us 914. Now, question 5 is asking me what is the cotangent of 240. Since we don't have that in the calculator, it might be worth checking this in terms of sine and cosine. Remember that the cotangent is the cosine over the sine. So this is cosine, and this is sine, right? And now there are two alternatives to work on this. You either use your special angles that you are going to be able to use a cheat sheet for the final exam. So you can find out what the cosine of 240 degrees is. And what the sine of 240 degrees is. Right? So the cosine of 240. By the way, you can kind of figure out how much this is by drawing the unit circle. Right? And 240 is how much is a multiple of 60. We have, that is one more here. Since we have 180 plus 60 is 240. So it's like we have 61s, 62, 63 times, 64 times. And so we can think of it as calculating information with an angle of 60 degrees as well. So if you want to get that information in that way, that's another option. You can do it with the adjacent here, and so for 60 the cosine is going to be minus 1/2. And so once that you have the cosine, you can also compute the sine. There are multiple things that you can do. You can do it with a calculator or plenty of different ways to approach this. When you get this bar, then you're gonna get that this is minus the square root of 3/2. And so simplifying this will be 1/square root of 3, which is answer D. Okay. But again, one of the things that you can do is set your calculator, check what the values are that you're getting, and see that the ratio is consistent with the values that you can obtain in the calculator for this. So there are two different ways of approaching this type of problem. Now, 6 is also similar in terms of the things that you need to do. And you need to find all the solutions of cosine of x equals minus the square root of 3 over 2. We actually just find out that that was related to 240. And to 240 is 4 pi over 6, right? 4 pi over 6. Yeah. Yeah, this is the cosine. No, it's gonna be 5 pi over 6. Five pi over 6. Yeah, so 30 degrees. Pi over 3. All right, so the way that again, there's two ways to go about this, and one of them is just use a calculator, right, and obtain the values that you're gonna get. But the other one is just go through the unit circle. As you can see, all the results are in terms of pi over 6, so indeed it gotta be something that is a multiple of pi over 6, because the cosine is negative, then minus, sorry, the eraser here, because we have a negative cosine, so we're talking about in the unit circle of a negative value of the cosine. So you're gonna have an angle that is here on the second quadrant, and you're gonna have an angle that is here on the third quadrant. Okay. And so of course these are going to be angles that make sense over here. So how much is this is pi over here, and pi also can be seen as 6 pi over 6. So this will be one less if we're taking pi over 6 here. You will have the opportunity to check for the angle 5 pi over 6, and of course over here the reflected angle here is going to have probably 2 pi over 6 more, so that's going to be 7 pi over 6. Okay. You can look for corresponding angles. The other option, notice that from the options that you have available, something that is in the second and in the third quadrant, none of this makes sense. This one is not in the corresponding quadrant. Only this answer here is in that quadrant. Similarly here, pi over 6 is in this quadrant, and this one 11 pi over 6 is in this quadrant. So that's one way to disregard the rest of the answers. Just know that it's not possible for these other angles to be in the correct quadrants, where cosine of x is minus the square root of 3 over 2. Now question 7 is about to determine where sine of x is minus 0.83. Now this is a similar situation, although the only thing is that we don't have a fixed angle, but we have a negative sign. So now we have this situation, and because it's a negative sign, it gotta be something that is after pi and something close to 2 pi. Those are the two values. Also notice that because of the way that the answers are being given, then you gotta be careful with the values that you're going to obtain. Of course, you can go with your calculator and do sine to the minus 1 of minus 0.83. And very likely you're gonna get this value, but you're gonna get a negative value. So you gotta make sure that this value that is over here correspond to a positive angle, like the information that you're supposed to obtain in here. Okay. Notice that from the options, the only one that has an angle here and here is going to be this answer. 4.12 is after 3.14, so is this angle corresponds to this angle over here, and 5.30 is very close to 2 pi. None of the other angles is actually on the correct intervals here to 2 pi. C cannot be because it's not in 0 to 2 pi. You have negative options. Although one of these options might be okay, but it's just not the correct interval. Now, 0.98 is in the first quadrant, so it's not that one. And 2.16 is in the second quadrant, so it's almost not that one. So a lot of this is like disregard the answers that are not in the correct positioning. And that comes without even making a calculation. That's just from the fact that in the unit circle, sine corresponds to the height. And so that's telling me, hey, this line is minus 0.83, is negative below the x-axis, and it gotta correspond to those particular angles. Now for the next one, or the next way to approach this is, once that you get this value, you're probably going to get the answer minus 0.98, since sine inverse is going to give you values between minus pi half and pi half. And so this, and when you obtain this, what you gotta do is you gotta add 2 pi minus 0.98, because this is giving you the acute angle, and then you're gonna get this value here, which is gonna be the 530, and then after that you can just take pi plus 0.98, and that's what's gonna give you this value here, the 4.12. And those are the two things that you can do for approaching this type of question. Now, question 8 says the equation of the smallest circle passing through minus 2.2 and 0 is, and so at that point you gotta remember that the smallest circle between these 2 points is assuming that these points are the extremes of the circle. So you gotta find out the middle point between them. This is assuming 0, 0, and this is minus 2, 2, so you're actually gonna find the center, and the center is the middle point of those. And so that means 0 minus 2, so plus 2 over 2, and then 0 minus 2 divided by 2. So this means that it's the point 1 minus 1. Wait a minute, I'm doing it backwards. Is the midpoint. The midpoint. So the midpoint is minus 2 plus 0. Right, so it doesn't get the opposite sign. And here is 0 plus 2 divided by 2. So it's opposite sign here. Gotta be careful with that. Okay, so this says they gotta be x plus 1 square, and this says that gotta be y minus 1 square. That is gonna change a lot, and you can see that there's even the distractor here for that situation. Most of the other answers are correct, so you gotta be careful with doing incorrectly the center. But otherwise, most of the equation here, they have that, so we're not gonna be able to pick easily. Now we have to calculate, this is the center, so we're gonna calculate the distance from this center to one of the extremes. I can use, of course, the distance to 0, and so that's essentially telling me that the radius is gonna be this minus this square, so 1 square, this minus this square, so this is just gonna be square root of 2. The radius is gonna be square root of 2, but because the equation is the radius is square, then the answer gotta be B. Okay. And so that's question number 8. Now, question number 9 says the height of a mainsail is 24 feet and the base is 32. So we have, again, the mainsail of a boat is a triangle situation. this is incorrect. Let me see if I can actually use a figure. Nope. I can use a line, I guess. And so we have that the base is 32. And we have that the height is 24. And now we're reducing. And we're reducing the vase by 6 feet. So this means that now this is going to be 18. And I don't know my new vase. So this is going to be some new B volume. We can use similarity of triangles here. And so 24 is to 18 as B is to 32. So this is the similarity of the big triangle with the small triangle. And when I multiply that 24 times 32 divided by 18, then I simplify this, and I'm just going to get that this is going to be, which is this. All right, I can get a 6 out of here, right? This is 6 by 3, and I can get a 6 right here. So this is 4. And 3. And now by 32. Wait a minute. I have this backwards. 24 is to 18 as 32 is to B. I have it up backwards on the order. Yeah, so the big one is 24 and 32, so they gotta be in the corresponding sides. So B is 32 times 18 over 24. We can learn from this mistake by realizing, oh, I'm doing 24 over 18, so the height over the height. And I also gotta make the base over the base, but they had to be on the corresponding places. So the big height gotta correspond to the big base, and the small height gotta correspond to the small base. So now that we can break apart this here. So this is 4 times 8, and this is 6 times 3, and this is 6 times 4. So now I can cancel the 4, I can cancel the 6, and 3 times 8 is 24. All right. And that is that'll be the answer for number 9. Now number 10 says the following graph represent the height of water of a function of a volume of water as is poured at a constant rate into a container. Which container is representing this graph? And as you can see, we have multiple containers. We have a cylinder. We have a cone. We have 2 cones, but we have a cone where initially is quite big on the bottom and then small at the top, and then we have the inverse situation. We have something that starts small and then it gets to be big in volume, and then we have a sphere and half of the sphere. So we gotta be careful in here because essentially we want to check the height of the water. So that's what we're checking. And so of course initially here the height of the water is not gonna be very big, and this is gonna take a lot to fill out in this cone, and then it is gonna fill quickly when it's getting to the top because there's less space. And so the height is going to be increasing when it's going to increase quickly when we're getting to the top. So that situation is reflected here. And so that's why the answer here is B. Notice that that doesn't happen with other things because, for example, this sphere will start with a small height, but then it will grow. It will grow. It will grow quicker for a while. Then it'll start getting to like a maximum point when it gets to the middle, and then it starts decreasing the amount of how fast the height gets to be. Similarly with this, this is going to reach a plateau when it gets to the maximum, so that doesn't happen. And this one is very constant the way that everything grows, so this should be like a line in the way that it grows. So the only one that can represent accurately this movement where initially it takes a lot to start increasing and then increase really fast is this cone. Now for question 11, we have that the volume of a sphere is 4 pi over r cubed, and we want to know, and so we have that the radius of the sphere is r1 and it's increasing to r2. We want to check for the change on the expression of the volume. This is simply the delta, and you're checking for the difference between B2 and B1. And so you're doing 4/3 of pi r cubed. And so this is r2 minus 4/3 of pi r1 cubed. And so we can factor the common elements, 4/3 of pi, and this is r2 cubed minus r1 cubed. Of course, we don't want to leave that one, and this is a difference of cubes. We want to obtain the delta r, so we're going to use the difference of cubes. This is going to be r2 squared plus r1 r2 plus r1 squared, and then we have r2 minus r1 that is going to transform into the delta r. So we search for this formula here, and there is only one formula that is similar, that's B. And so that'll be the answer for this question. Now let's go to the short answer questions. So the first one says this point are in the unit circle and they're equally spaced. So they're equally spaced, and notice that we have 1, 2, 3, 4, 5, 6 on the top. So it means that each of these parts measures pi over 3. All these points are distance pi over 3 away. So what point corresponds to 5 pi over 3? Well, it's going to be the point F. Wait a minute. 1, 2, 3, 4, 5. No, sorry, this is not pi over 3. This is pi over 6. This is pi divided by 6, obviously. So it's not pi over 3, pi over 6. So this will be 2 pi over 6, obviously, will be pi over 3. So every 2 is that we have pi over 3. Every 2. So 2 pi over 3, 2 pi over 3, 3 pi over 3 here, 4 pi over 3, and then 5 pi over 3 will be here. So it's K. Now we want to know what are the exact coordinates of the point H. Now notice again, this is pi over 6, so this is 6 pi over 6, 7 pi over 6. And so we got to calculate what the cosine of 7 pi over 6 is, and the sine of 7 pi over 6. And that is the point, the coordinates of the point. If we plug that in the calculator, or we use your unit circle, we're going to find out that this is minus the square root of 3 over 2 over minus 1/2, or together with minus 1/2. Now we want to know which point has the coordinate minus 1/2, and so minus 1/2 is going to be down here. It's going to be this possible, since it's like right in the middle over there, and that's going to be the point H and L. This of course is like 7 pi over 6, and we notice that that's one of the y coordinates that we have from before. And so that reflects on the other side. That's going to have the same coordinates. Now for the radian measure of the point I, which is this one here, we'll of course have 6 pi over 6. We have that this is 8 pi over 6. So 8 pi over 6, or this is 4 pi over 3. Any of the two works out well with this. Now, number 2 of the true answer is find the values and parameters of the function f of t equals a plus b sine of c t minus d. Notice that this is very similar to the things that we did in the first exam. We can find a lot of information from just analyzing the numbers of the function. So one of the good things to find is the midline. The midline is a, and you can see clearly that the midline is 2. Another way to see that it's 2 is just take the maximum and the minimum and divide by 2. So it's like 5 plus minus 1, which is 4, divided by 2, that'll be 2. Now, once that you determine that this is the midline, then you can check that the amplitude is going to be 3. And so once that you know that the amplitude is 3, then with that you can probably guess maximums and minimums if you need it. Although you can see here that you have 5 and minus 1. This seems to be shifted around a little bit. This t minus d. Notice that there's a certain amount of shift that we have for the regular sine or cosine. We can also check by the maximums. The distance between maximum, notice, is 2 and then is 6. So the distance between maximums is 4. So we can know that the period is 4. And so if the period is 4, but at the same time that is 2b over pi, 2 pi over b, sorry. So then we know that b is going to be 2 pi over 4. And so that is pi half. And so that is precisely the value you see here. Sorry, this is to be 2 pi over c, according to this. And so now that we know that this has this speed, it has a speed pi half, we notice that this is pi half t, and then this value here is going to be is going to show what the corresponding shift is when we take c divided by d, and so we can see that everything seems to be shifted by 1 unit. Okay, and you can see this because this point, which is supposed to be in 0, is shifted to 1. Assuming this is a sine function. Okay, so with that we found all the values that this function has. Now, for question number 3, we have to find the side c, so the hypotenuse, and the angle theta in degrees if we have that a is equals 17 and b is equals 13. And we want to round values here to 1 decimal place. So we can use values that in a and b that we know. We can use tangent of theta. And notice that theta this time is here. So the opposite is a, and the adjacent is b. So this is 17 over 13. And so with that we can find theta using tangent inverse. And that's going to be on degrees, it's going to be 52.6. Now that's for just finding theta, but if I just want to find c, I just need to do c squared is equals to a squared plus b squared, or that'll be 17 squared plus 13 squared. And so c is the square root of that. And so that's going to be 21.4. Now, last but not least, we can work a little bit with values to fill missing values on this table. We have the sine, the cosine to the -1, and the tangent to the -1. And for this, it's important to remember where these things are supposed to land. So sine to the -1 is a function that is going to land between minus pi half and pi half in the unit circle. Or that's the range. All these functions, they come from -1 to 1 here in this situation. Cosine is from 0 to pi. Cosine to the -1. And tangent to the -1 is also landing between minus pi half and pi half. Now with that information, then we can say, oh, okay, so let's find the values that corresponds to that on the unit circle. And so if we have that x is minus square root of 3 over 2, that correspond with an angle in the unit circle. And so if I do sine to the -1 of minus square root of 3 over 2, then you're going to find out, oh, okay, so this is going to be corresponding to minus pi over 3. At the same time, notice that sine of pi over 3 is going to be giving you square root of 3 over 2. So it corresponds. Now, in the same fashion, then sine of pi over 3 corresponds with square root of 3 over 2. The only difference here is the sign, but remember the sign of the negative sign is pulled out by the sine function. Now with 0, 0 corresponds to 0 on the sine, so that one is good, no issues in there. With the cosine, if we're getting -1, if you remember the graph of the cosine achieved -1 on pi. So cosine, so if x is -1, cosine to the -1 is going to be pi. The relationship with pi over 4 is something that you probably know at this point with the square root of 2 over 2. And if we have 1/2, this is going to be related on the cosine with pi over 3. All this information can be obtained with the unit circle. And remember that for your final, you're allowed to have a cheat sheet where you can just have your unit circle information. Now, if x is -1 over square root of 3, then you can remember that this can be related to a previous question, and we saw that that was occurring at pi over 6 multiple. But because we have a minus, then this is going to be a minus pi over 6. Then similarly, notice we want to know what happens when we get pi over 3 with a tangent to the -1. And that is a very specific value that we can get with square root of 3. You can do this with the calculator, of course. You plug this value and then you can get this value here. Another way to remember is you can check, well, if tangent to the -1 of x is pi over 3, then the meaning of that is that x is tangent of pi over 3. You can do this one easily with the calculator and find out that this is the value that you're going for. These two things are equivalent. On the other hand, if you just have that x equals 1, the other way to approach this type of question is just plug what 1 is. So you have tangent to the -1 of 1. And then is that you obtain that this is pi over 4. And remember that this is also saying, well, if tangent to the -1 of x, sorry, if you have tangent to the minus 1 of 1, a certain value, y, or let's call it theta because it's supposed to give me an angle, then we're saying at the same time the tangent of theta is 1. This is the two sides of the same coin with this. And where the tangent of theta is 1, where sine and cosine are the same. And where sine and cosine are the same, only in the, or specifically in the angle pi over 4, and maybe in the 5 pi over 4 as well. But among this domain, which is where it should fall, this is only going to produce you pi over 4. All right, and that is the end of the short answer questions and the multiple selection questions.